here in Philadelphia. Where are you at? You're in Delaware.
Yeah, you're. I don't think you're in Philadelphia.
I'm in Philadelphia. Yeah, this is not New York City. It's too hot and too crazy in New York City right now. I'm not going there. Hey, so today we are talking about zero knowledge proofs, something that we wanted to go over today because I think that it's been in like whenever I look at my cell phone and I'm kind of like going through like Google News or whatever, uh, there's always been basically I didn't initially know what a zero knowledge proof was, and I wanted to basically figure it out. And today we will not just go through what a zero knowledge proof is, but why does it matter, and the why and the where and the what as well. What do you think about that, John?
I think that's a solid plan for the evening.
Cool. So, all right. So, what is a zero knowledge proof? What's up? Why do we care? That's like the biggest reasons. Like, why do we care? Do you want me to take over the screen? Here, I'll give it to you. Okay. So basically, when we're coming down to it, we are basically facing a scaling problem in Ethereum where at one end of the spectrum, we wanted to have something that approved upon Bitcoin. So we tried to give it constraints. For instance, gas is necessary. So it's not very like a part of why we should it. You can make calls on a contract, but what if you had? There's not like an infinite amount of space and resources for someone to do that. So while we're mining Ethereum, we need to pay gas in order to deploy contracts, call certain items, do pretty much do anything costs gas, right?
Yeah. In fact, every month, Ethereum token transfers cost users over $2 million in gas fees.
Yes.
Currently.
And I guess like what that comes down to is it's not necessarily that we're shooting ourselves in the foot, but at the same time, not only is it difficult to create a decentralized app, but it's also expensive, and sometimes what the utility you get out of it may not deliver. And that's kind of like what we're going to explore today is the why. Is there has been a series of something we call a zero knowledge roll up, which will layer on top of a zero knowledge proof in such a way that we can bring off the heavy lifting, the things that cost a lot of gas on the Ethereum blockchain, off chain, do the computation, and then bring it back to the Ethereum block space without incurring any gas. Actually, well, not any gas, but drastically lower amounts in like powers of 10. So really what that comes down to is, you want me to share your screen? You're looking at something cool. All right, we'll save it. Just bring it back up. So basically,
we can save it for a little bit.
Okay. So what I'm thinking is that one, we don't understand why. There's like probably in the mind of the listener who doesn't know what a zero knowledge proof and why we need it. We should go into basically, if you want to have it prove something provably fair, or just to prove that no one tampered with the information going off chain, then we have to basically prove that it wasn't tampered with, and we have to prove that something happened where. But we don't know what happened, but we do know it did happen, right?
Yes. a zero knowledge proof is proving you know a value without, or you know a secret. The secret can be, my name. It could be the coordinates to my secret treasure. It could be anything. You prove you know it without revealing what it is to anybody, except the person who knows it, obviously.
Okay. So, I mean, that's the why. So, if we follow that logic that we knew that we did some sort of complex computation somewhere and it happened, basically. So, when we come back and we bring that information back to the Ethereum blockchain, we have to prove that, one, that it's not wasn't tampered with, and that we knew that it happened, and also the value. So I think that the why is also in terms of like doing all that expensive computation elsewhere allows us to really save money, save time and effort on what opening up the gates of development, making it cheaper and easier for the introductory user as well. So we're going to jump over to you.
To
John?
me,
Mm-hmm.
All
right. I guess we'll just wait, I guess.
Well, I could go through, read through.
Yeah, I just kind of like want to talk about what it is on, like, just like on a more visual level, or right before we get to the coding aspect, just to know like what is a zero knowledge proof, what it would look like, and then why we care for Ethereum specifically.
Yeah. All right. So.
Yeah, let me go to you.
I guess so. I guess we're going to start with where we always start, Wikipedia.
Okay, I'm down. Okay.
Zero knowledge proof. In cryptography, a zero knowledge proof or zero knowledge protocol is a method by which one party, the prover, and go zoom in forever. Is this good?
Full screen that? No, can you like full screen it so it wraps your whole screen?
How about this?
Nice. Yeah, now zoom in.
Kind of annoying because I can't see what's happening, but this is the curse of having one monitor.
Yeah. Can we get like one more zoom in? All right, we'll deal with that. Cool. Yeah, we kind of go. I think maybe we should have like a Wikipedia button, just like have it swoop in, like we don't know, Wikipedia does. Let's see. So we mentioned one party, the prover, because that's kind of like what we're going to do in code later as well. The prover, and there's one party to prove another party, the verifier, that they know a value X without conveying the information apart from the fact that they know the value. The essence of a zero knowledge proof is that it is trivial to prove that one possesses knowledge of a certain information. Simply revealing it, the challenge is to prove such possession without revealing the information itself. Okay, cool. That's kind of important too, because we don't want to let the person know actually what we're trying to compute. We just want them to do maybe a computation and just have that exist off chain as well. So security is a part of that.
Yeah, and so zero knowledge proofs are already in use. It's not just for scaling Ethereum. Their really invention was for privacy, because you're proving you know a value without telling them what it is. So that resulted in two pretty important protocols and currencies, Zcash and Mimblewimble, which resulted in Grin/Beam.
Yeah, okay. So that, very cool.
And as you know, both these currencies, I guess, and Monero, you can't forget that.
Can't forget it.
Though Monero is a bit unique in how it works. But so So all these currencies allow you to send a currency from one user to another, and is impossible to trace, or nearly impossible to see where one token came from.
For sure.
And that's all through zero knowledge proofs, because instead of the way these things work is when a user receives a token, they receive access. Basically, they sign a contract with someone else, basically allowing them to create a proof in zero knowledge that they can now own a token. So to even say, so to send a token to someone else, you using your private key to essentially sign and generate a proof that you own this token, thus altering the state of the blockchain, allowing someone else to now say, to create a proof that they own this token instead of you.
Let's scroll down. Maybe we can get like a little visual on what that is.
Okay. I mean, let's see what visuals.
Ooh,
the Alibaba cave.
Okay, so Peggy randomly takes either path A or B while Victor waits outside. Okay, cool. Victor chooses an exit path. All right. Peggy Reliable appears at the exit Peter names. However, let's see. In this story, Peggy has uncovered the secret. Oh, let's get to that. The Alibaba cave. There's a well-known story presenting the fundamental ideas of zero knowledge proofs.
Oh, I get what's happening, because she has to know the secret to go to the right to exit via the right entrance, but she doesn't have to tell Victor the secret. But she can prove she knows it because she was able to leave through the right entrance.
Oh.
And I didn't have to read any of that. Well, that's what I'm assuming it is. Maybe I'm completely wrong, but
label left and right from the entrance A and B. First, Victor waits outside the cave if Peggy goes in. Peggy takes either path A or B. Victor is not allowed to see which. Stop right there. Victor is not allowed to see which path he takes. Then Victor enters the cave and shouts the name of the path he wants her to use to return, either A or B. Choosing at random, providing that she really does know the magic word. This is easy. She opens the door if necessary, returns along the desired path. However, suppose she does not know the word, and she would only be able to return to the path that Victor would, the name of the same path in which she had entered correctly. Okay, if they repeat this trick many times, say 20 times in a row, her chance of successfully anticipating all of Victor's requests will become vanishingly small, about 1 in a million. Okay.
Yeah, that's a well-known. I guess that's example of a well-known protocol.
The Alibaba cave. Okay, weird. 2 balls to the colorblind friend. You said, yeah.
These are some crazy examples. Abstract, interesting.
I know, it's kind of wild. Can you please post? Hey Anna, can you please post link to this? Yes. I'm not sure where though, because this is going out to so many platforms. It's mind numbing.
They need a link to what we were on.
I guess you don't really need a link. Just Wikipedia, zero knowledge proof.
Yes. Where's Wally?
Where's Wally? But we could probably do. What I'll do is that I'll make a stream. I'll post the link inside of the comments below, because once this stops being live, it will be a video. You went in the Blockchain Center Telegram group. Okay. Let's see if I can do that. Just keep talking while I do this.
Okay. So all these examples are actually these hypothetical odd stories are examples of more general interactive proof systems.
Say that one more time. Blah, 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 blah. That was a tongue twister.
Interactive proof systems.
Okay. So when you say interactive, let's just not. What do you mean?
Basically, basically interactive because they require a challenger and a prover, and the challenger gives you a challenge, and then the prover has to try and fulfill that challenge.
Ah.
Yes. And there's always some probability, though, that the prover can just guess and win, as in the first example with the cave. So if we go back, Victor just picks some A or B randomly, and Peggy, whether she knows the secret password or not to open the door, has a 50% chance of guessing the right one. Now, this example doesn't actually make a lot of sense because he'd only have to do it twice, but that's a simple example. That's basically a simple analogy of what actually happens in interactive proof system. And in every proof, there's a given probability that you could just guess because all cryptography is based on randomness. And cryptography is only hard because the probability that you can guess is very low. But so there's a more technical definition, and is a zero knowledge proof must satisfy three properties: completeness, which means if a statement is true, the honest verifier will be convinced of the fact by the prover.
Okay.
Which is in itself pretty obvious, because it would be kind of pointless to have a proof of something that was nebulous and you wouldn't know, you couldn't be sure of. Mm-hmm. Basically, it's very mathematical. It's either the answer is right or wrong, and it's you can calculate it. Soundness, which means you have a very small probability of guessing.
Okay. Which is basically every cryptographic problem, because you probably can, it's just not likely.
Yeah, I could type in a bunch of random numbers and hope I have your Bitcoin private key. And if the gods wanted to, I could guess Satoshi's Bitcoin key.
Uh-huh.
But realistically, that would never happen.
Yeah.
But that would be winning the ultimate lottery, to guess Satoshi's Bitcoin private key.
Yeah. At that point, that's ridiculous. All right, Anna. So this is what you're gonna do. Anna from the Blockchain Center. She's hitting me up on in the comments, and she's asking me for this stuff. What I'm gonna do is, Anna, you should add me on Telegram, or send it to me via Discord, because there's 90 apps that we can talk to. I'll hit you simultaneously through WhatsApp, Discord,
Telegram, Mattermost,
Gitter,
Keybase,
Slack,
Riot.
Yeah. I'll hit you up all through them simultaneously. Add me on all of them.
Google Hangouts.
Ooh, brutal.
I exist on every messaging app imaginable.
What about Zoom? We forgot about Zoom. Wait, you said Zoom?
No, I did not say Zoom.
Okay. Yeah, it's kind of exhausting.
Yeah, and we're forgetting all the normal social media sites, which I guess all function as messaging apps too.
I guess, but literally, we're going live to all of those. So if you don't catch us, you can't. Stop giving your money to fake account managers who will promise huge returns. Oh man! Thanks for the comment. Just send me $100 and I'll inbox you $200 later. Yeah, that's horrible. I think we gotta get some sort of bot filter.
Okay, you're reading comments. That makes sense.
Yeah. Ooh, you know what? Yeah, you want to really impress? You want to really impress me? Can you pronounce me what that latex is saying? Because I know that it's
which one? That was this where my mouse is.
Yeah. So what is that? That's for all X
within the subset L. Z's z within the interval 0 to 1, where p, let's see, I don't know what the view means. That's the crazy part.
Crucial. Wait, that's a
Where
verifier where the view of the verifier that says PP probabilistic polynomial time. This is that V with the hat. V hat.
yeah.
Big V hat.
Yeah, where p arrows in on v of xz equals s of xz.
Oh, the formal definition of a zero knowledge has some computational model in which most common with a Turing machine.
Is a record. Okay, they just kind of made it up here, where it's just like view is a record of the interaction between px and vx, which is the prover and verifier.
Yeah, I'm in a group on Facebook that if it's written in latex, it must be true. Like, wow.
So these are the three important things to remember. Completeness, it can be easily shown to be true. Soundness, it can't be faked. In zero knowledge, you're not giving away anything about the value you're trying to prove. Those are the important things to remember. And so they give practical examples and math. Hamiltonian cycles, those are pretty exciting.
Math and stuff.
Yeah, so we are going to give one of the simplest examples and a very practical example using the magic of hash functions.
Oh, yes. I'm getting my things together right now too.
Okay, and Eric he is at a better computer setup, as you can see by his magical screen.
It's magical. Let's see if I can actually get the magic to work. Blah blah. Let's see if I can do it. Okay.
It's gonna demonstrate a very simple knowledge proof called hash chains, or using a technique called hash chaining.
Hash chaining. Yeah.
Yes. Which is simply repeatedly hashing of a single value. So that is where I start with the value, I input to a hash function to get a new value, and then insert that again into the hash function again and repeat. Okay. And you can do that continuously to produce new values.
Okay, so I'll drive, but you can talk over me. It's fine. I'm just setting up my environment. Boop, boop. Okay.
Yeah, and you can do this and if you know this, you can win a hackathon.
Yeah. Let's see.
As I did with this technique.
Oh yeah, well, tell us more about that. Which one was it?
I think it was called Future of Blockchain. Okay. Maybe it was
many?
There's way too many hackathons. But our project was called Pop Glow Machine on the Tezos blockchain.
Okay.
And Tezos is a fascinating world. We built probably one of the best dApps that exist on the Tezos blockchain right now. And I think it was sponsored by Oxford. So we were up against like a lot of intellectual people.
That's cool. It happens like that. So do you see my screen?
Let me see. I have to. This is the problem with having only one screen.
You're right. Yeah, but I already switched to my screen. You're good.
Okay.
You're in the clear. So I want to make a new directory real quick. And I'll call this, what should I call it? I'll call it zero knowledge proof. No, proof. Okay, and we'll make a new file, and we'll call that zero dot. What did you say we're going to do? Like, we'll call it hash.js.
Yeah. The more Wikipedia definition of hash chain is a successive application of a cryptographic hash function to a piece of data.
Say that one more time.
Is a successive application of a cryptographic hash function to a piece of data.
Okay, cool. Yeah, we got a lot of people watching now. What's up? We are live coding on what it means to do a zero knowledge transfer. So let's see. So I'm going to, if you leave a comment on Facebook or YouTube, then we will know who you are and I can respond to you live. If you have any questions about what John and I are saying, sometimes we will literally go over something and basically bulldoze right over questions that you may have. So if you're watching, holler me in the comments. I can watch some of them. I know that I get the Facebook and YouTube. I got that correct. Hi, Anna. What's up? Tell me if I'm doing horribly. Long time no see. Yeah, I didn't get to see you Tuesday. Let's see if she responds. Maybe not. So I'll do npm. We got there late. That's all right. npm init. Package name CK proof. Version 1. 0. Descriptions. Entry point. Yes. Yes. No. No. Me. License. No. All right. Yes. Okay. Because I did that, I need to install something, right? I need to do npm install web3-utils, correct?
Mm-hmm. And web3-utils is a very nice JavaScript library for cryptography.
Okay. Why are we using it?
Because
give me the why.
The why is it contains all the utilities of Web3. So Ethereum includes a lot of encryption functions, and things to encrypt, to do all the hexadecimal formatting and hashing that involves on the Ethereum blockchain, right? And includes the big number library. So if you want to, includes the SHA-3.
Okay, so let's
which
see.
is our choice of hashing.
Okay, so if I say node right now, that will go there, and I'll say. Let me bring.
And the cool thing about Web3.utils as a package is you don't need the full Web3 library, which is huge.
Okay, so if I say web utils and I hit autocomplete, I should be able to. There's SHA-3 and SHA-3 raw. Let's do SHA-3 and we'll say hello world. Ooh. There it is.
Yeah.
So it gives you all the libraries that you would need. What else does this thing have? Let's see, utils. I always try to snoop around. Let's see what we got here. No way. No, it's from way. Interesting. Blah, blah, blah. Let's see what we got here.
Yeah, so
it
gives you big numbers. You can convert bytes to hex. You can convert ASCII. You can convert decimal, UTF-8.
Way, ASCII, string, big number, is bloom, is contrast, in bloom, hex strict, topic in bloom. Okay, so this is talking about where it is inside of its consensus. Okay, there it is. Left pad, interesting. Pad right. What are do you know what a pad left and pad right do?
Yeah, they're really important.
Yeah, what's up?
This is a whole nother live stream, but for manually encoding Ethereum transactions according to the Ethereum ABI,
Okay.
all values are padded to 32 bytes. So if you have the number like 1 and you want to encode that as an argument to a call to your smart contract, you have to pad it with a lot of zeros. I think it's like 63 or something.
Okay.
And so, I mean, that would be a live stream where the gang manually encodes an Ethereum transaction.
It'd be like It's Always Sunny in Philly. Like,
Yeah.
maybe like Dayman will just come in and be like, we're going to encode the way that the binary interface does. All right. So
Yeah, I mean, we're in Philadelphia, so
hell yeah.
it's always cryptic in Philadelphia.
No. Nice try though.
Yeah, I don't know.
I'll let that one go. But you know what? It's cool because it's raining here, so it's not always quite. It's not always that. It's not always the case. Let's see if I can make this easier to read. Because is my big head in the way? Let me see.
It is over like the bottom left corner. But
yeah, that's good because I hid the other one.
I don't think that's the.
That's good though. No, that's what we want. At least that's what I want. Man. That's unfortunate. Because when I started the stream, it was yesterday's stream. Inside of the text. Hey Anna, if you're listening, can you have someone help me with that what's on the text? Yo, hey Scott. Yeah, Scott, West Philadelphia, born and raised. Scott, help me out. It seems like we have to edit the stream. I don't want to edit I don't want to take apart the ship while it's flying. So that would be bad. But if you can set Matt on that'd be great. Because that's not correct. People are going to come here like thinking about this is going to be sick with the panel. And it's just us. Talking ZK proofs. All right. So I incorporated web3.utils. Utils. Right?
Mm-hmm. Yeah.
Okay. Let's see what we got here. So let's walk it through it. I want to write a function here that essentially is going to take in two arguments, a number
Yes.
and a pre-image. Now, can you define to me what a pre-image is?
It is how can I put it? It is a value you are hashing.
Okay.
So
is that what? Okay, we'll say pre-image.
That's just generally a terminology for a value put into a hash function. In the case of utils.sha3, it is a string. Well, everything is basically a string or number in JavaScript or an object. But in the real world, a pre-image would be a bytes object, which is converted to a number, which, of course, is sent to the Keccak sponge function, which is what constitutes mathematically a hash function.
Mm-hmm.
And then it's output as generally bytes.
See, this is what I love about you, VS Code, is that I just installed with npm and now it's available to me. That's pretty nice.
But what goes into a hash function is called a preimage, and it's general terminology. I guess you call it host image or just a hash.
Yeah.
Because hash functions, have the property of being one way. You can't reverse them. So
which is like the whole concept of cryptography. Well, not the whole.
Yeah.
Concept,
so when you have the output of a hash function it's nearly impossible to guess what went into it unless you know.
Mm-hmm.
So basically you can, so if someone has, the hash value of a string, you can prove that that original value by revealing it. So
Mm-hmm.
that itself constitutes what's known as a hash locked proof,
Yep.
and fulfills two of the properties of a zero knowledge proof, but it's not zero knowledge because you're revealing what you knew,
Mm-hmm.
which is the original secret.
Yes.
So you can fix that by hashing multiple times.
Okay. So what we were talking about before is that I'm going to basically iterate through the number of times that we're going to do this. So we'll say 4
So
eyes
you already
was
hashed once, so so you need to do it n minus one more times.
okay. So I'd be like, if I is less than n minus 1. Okay. So we're just going to do it again. I'll do it n minus 1 more times. Okay.
I think you have to insert it back into itself. So temp would have to be the SHA-3 of itself, not the preimage.
Okay. Okay, and we'll return temp. So we got here. Okay. So what we'll say is let O equal to hash n time. I'll call this hash n times. Okay, and then we're good here. 10. Whoopsh. I wish I had like more sound effects. It'd be like, whoopsh. Oh, we'll do that. We'll say. So this is our secret hello, right?
Yeah.
Let's see, and then we'll say hash n times, and we'll go 23, and we'll say our secret again. It's a better secret. We'll say John.
Let's keep the Philadelphia theme.
Yeah, let's keep it to Philly. Well, let's see. Why are we so loud? Uh-oh, Kate Johnson's a bot inside of... Baby Yoda is on it. Oh, no. Baby Yoda. Is that who that... Is that Matt? Do I not know this? So we'll say let n equal to hash n times, and we'll do this 13 and 0.
Bro.
Oh, row. Yeah. Okay. So let's see this. So n is going to be, we can figure out what n is No, well, we cannot say figure out what n is, but we're going to. Let's see. Was that just
What?
blockchaincenter.com is in the house. What's up? I think that's Matt. Hey, Matt. I can't hear you, but thanks for helping out backstage. It's much appreciated. And maybe you can get rid of Kate Johnson because it seems that she is a WhatsApp bot. A private chat. Just changing the logo, lol. I don't want that. I want you to change the YouTube. I want you to change the YouTube. Oh well. So what we're gonna show here is that I'm gonna save this and hopefully it runs. No, not that hash. Okay, so let's take a look at here. All right, so I can actually look at it. Like, so, can you see me pointing?
Yeah, it looks kind of cool.
So this is the
Yeah.
first. So this is the hash of the first one, and this is little n and big N. But if I look up here, O and N have the secret that they know, right? And when that secret now is John. But the amount of times that you run hash times is different. And why is that important?
So if you hash something 20, so let's go the Bob and Alice example.
Yeah.
Well, the first obvious thing is when you hash something 10 times and then you recursively hash it 13 more, it produces the same value as if you hash it 23 times. Okay, but now to go back to why practically you might want to do this to create a zero knowledge proof is so Bob has the secret John and he hashed it 23 times as the challenge. And he asked Alice, "Hey, do you know the secret password? And if so, can you hash it 10 times, or can you create a preimage so that when this hash 13 more times produces this byte string, which I have here?"
Yeah, so they didn't have to know what it was to say that. They didn't need to know the secret to say that it was correct, which you can see here.
Yeah, because the only way to output small n would be to know O, and the only way to know O is to calculate to know John or John. Be more yes, to be more idiomatic. But unlike, as I mentioned before, a single hash lock proof, when you reveal O and then Bob can calculate N and show that big N meets small n, O is just going to be a garbled a bunch of hexadecimal values. It's not readable by anyone, and no one learns the secret. So it's zero knowledge.
Yeah.
And it's easy. It's sound in that you can prove it's true, and then it's what was the? Let's see. What was the? Let's.
Some other
It's sound in that it's almost impossible to guess. It would be nearly impossible to forge that hash until someone breaks the SHA-3, and it's complete, and that it is computationally deterministic to recreate. So you can calculate that it is true.
Mm-hmm.
So that's all the properties of a zero knowledge proof.
That sounds wonderful.
Yes. And what's also useful, this is also extremely useful in a blockchain for reusable hash locks. So if you want to allow multiple people to prove they know a password without revealing the password in the blockchain, this is one way to do it. Since, well, in an Ethereum style blockchain anyway, there are other solutions. However, in Ethereum, there is no private data. Everything you post and every transaction is there forever for everyone to see. So if you want to reveal a value without knowing the value, you can have a system like this where multiple people can reveal the pre-image hashes at different levels to prove in a smart contract that they know a password. Now, there's a limited number of times you could use this, but it's much better than one.
So I guess that this allows us to start John's John. Yeah. This is John's John. I mean, if it's anyone's John, it's John's John. So that's why he's on. That's why he's here, honestly. And that, I wanted to go over. So we know the how now, and we kind of mentioned the why earlier in the stream. But can we go back? Can you bring up like I guess like a shootout of all the different ZK rollups that are available, because that's kind of the why.
Okay, this is the jump from what is a zero knowledge proof to what is a ZK rollup.
Yes,
that's huge.
Now, it is a big jump, but I want to move from. I want to go from mountaintop to mountaintop with you, and that we have some time left on the show, and I want to start doing this, but I'm not experienced. Rosa, if you stick in chat, you can join a Discord and we can talk about any topic you'd like. In fact, what I was doing right there wasn't all that impressive in Node, so we can do that if you'd like. It just looks impressive with like lots of random characters.
I mean, yeah, and it has there's a lot of odd names. Like if you look through like all those functions, and you didn't know what a bloom filter is, or
for sure
any of the padding or any of the encoding systems, it's overwhelming. I was overwhelmed like 3 years ago when I looked at all this stuff.
It was many naps ago, and now he's here.
Yes,
many naps. Really, that's all this is, just reading and taking a nap. I'm a nap guy myself. Anytime I'm any mentally inconvenienced, I'll take a nap right now. Nap right on stream. It'd be great.
Yeah, I need to do that. I don't take a nap, and I think that it would be smarter for me to do so.
Oh yeah. You gotta impress nobody. Take a nap. Sometimes you just gotta take a nap. Yeah, Rosa, email me at eric@blockchaincenter.com so I can get your email. And actually, I'm developing a curriculum with John right now to take. If you're not experienced, if you're totally not experienced, then it would take a little bit longer. But I definitely want to take someone from zero to hero within 11 weeks with what we're trying to put together. It's actually the best. And I think we touch on cryptography topics like this and beyond. And before, I think I was just writing my module on the Enigma machine. Oh, I digress. Can I share your screen?
My screen, yeah.
I can see your screen. It doesn't look ready yet.
Oh, okay. I was sharing a different window. Let me go to what I was looking at right now.
Yeah, that is the one that's changing. I can see.
Okay.
That. Can I bring yours up?
Yeah.
Okay. ZK rollups.
Yeah, we're in ETH Hub, which is a
website.
Yes, very focused on Ethereum. I don't know if this is part of the Ethereum Foundation. It looks like it is, but it might be might be fooling me.
Yeah, Rosa's in chat. She's
anyway.
excited. People are watching on Facebook. thank you, and smash that like, subscribe. You will literally get every time we go live here at the Blockchain Center with excellent curated content. We'll go right to your phone. Can you give me like one more zoom in?
Okay.
Hello, can someone full of truth explain to me how this online trading is? Please, I'm really interested. You know what? This is the problem. The YouTube title was misleading. This is definitely not trading. And we just debated you. Sorry.
Yeah.
You just got debated.
Now, this technology will eventually allow you to trade with less fees, which is cool.
Yes, which I can see that's happening. You know, that would, let's see. Yes. Oh my God, I can't wait. Sweet. Let's see. Actually, I can press that up here. Ready? Yes. Oh my God, I can't wait. Bam. Thanks, Rosa. Thanks. Rosa's hype. I'm down. See now. See. Scott's John's John. For those at home who can't spell John, there it is. And they're Jimmy's, not sprinkles, and it's water ice.
Okay.
All right. I was looking a little just peppering in Philadelphia since we're here. Can we get me one more zoom in? Just give me one more.
Okay.
Okay.
So
ZK ropes are one of the options of being developed for layer 2 construction that increases scalability through a mass transfer process rolled up into a single transaction.
yes.
All right. The zero-knowledge proof approach is present to publicly record the validity of the block on the Ethereum blockchain. Zero-knowledge reduces computing and storage resources for validating the block by reducing the amount of data held in the transaction. Excellent. Wonder if Rosa actually sent me an email. No, not yet. Okay. That was just my eyes playing a trick on me. Cool. That's actually good. Yeah, because even if you were to store something very small on the Ethereum blockchain, it costs a lot. So even storage, you don't even want to like say, oh, okay, copy these two variables and then add them together. Because we kind of take that for granted when we're working with computers. It's like, oh, okay, add these things together and save them. But there's no hard disk here because we're on the Ethereum blockchain and everything is extremely, like basically dumb. It's so dumb, in fact, that we're dealing with smaller amount of storage space than they had on the space shuttle, and not smarter than a Nintendo.
Mm-hmm. Okay. So.
Mm-hmm.
Okay, so back to the ZK rollup.
Yes.
So this is like the simple overview. Transactors and relayers.
Yeah,
a transactor is you as the user of Ethereum.
Okay.
You create a transaction, which is the data of the what you were sending, who you're sending it to, and the fee you would pay. Let's see. And my cat wants to come here, but
you got another co-host.
Yeah.
The cat can come on stream if it wants to.
See if it wants to.
All right.
No, it's just gonna sit there next to me.
Okay, that's fair.
Okay. Anyway, so the real meat of it is the way ZK Roll works is there's users called relayers.
Okay.
They collect a large amount of transfers to create a roll-up. And what that is, they are rolling up all the transfers into a compact cylinder. Yeah, just like the fruit roll-up.
Yeah, I was thinking about like a carpet, like with like some gangster rolling somebody up in some carpet.
Yeah, they're reducing the area of all the transactions into a small cylinder, right?
Yeah,
and then they
Doing
generate
nothing.
a snark proof, which
Yes.
is a class is one acronym that that classifies one type of zero knowledge proof. And so a snark proof, of course, is a hash that represents the delta of the blockchain state. State refers to state of being. That's the most meta thing
Oh,
read in a Ethereum blog.
okay.
Right, and so this compares a snapshot of the blockchain before the transfer to a snapshot of the blockchain after the transfer, and then reports only the changes in a verified hash to the blockchain. So essentially, you're creating a hash that proves, thousands of the results of thousands of token transfers.
Yeah, whenever I think about it too, and when I learned about what ZK Snarks was, which if no one knows what that means, it is the zero knowledge, succinct, non-interactive argument of knowledge. That's the snark. Either way,
That's good. I didn't remember what that stood for.
I know. I think that's what we were kind of choking up on, but thank goodness we have the internet. And I'll act like I remembered. Anyway, it's basically, I was thinking about like their cylinders, but the way that I thought about it was like these cylinders are spinning, and that you kind of like jump from one cylinder to the next, but you don't know. You can prove that the transaction, are on that cylinder, and you keep on basically being relayed back and forth, and you can jump from one end to the of this like dark hallway and then come out the other side. So you can say like, oh, okay, that did happen, but you don't know what it was or where it was. Let's see. Pros and cons. What are we doing here? Adapts running a ZK roll-up scheme pay less in transaction fees. Creating zero knowledge proofs requires a large amount of computation. The implementation
Yes,
is
and this is compared to optimistic rollup and plasma. And yes, there's other rollups.
There's other flavors of rollups? No way.
Yeah, but there's a whole other stream to compare the different rollups.
Oh man, we got mad hackers. Not hackers, spam bots. Text this number on Instagram or WhatsApp. He's the best hacker. He will do the best job for the best price, no doubt. Okay. Wow. Maybe there's just bots watching us.
So are we gonna go through the pros and cons, or
yeah? Let's
okay.
We got a little bit of time left.
So,
reduce fees faster than optimistic plasma. Blah blah. Okay, let's see. Yeah, so it looks like less data is contained in each transaction, increases throughput and scalability of layer 2. Does not require fraud, game verification like optimistic rollup, which can delay withdrawals up to 2 weeks. Holy.
Yeah, that's why it's called optimistic rollup. So,
okay.
Again, all the different kinds of rollups are its own live stream. A whole another hour of excitement. But to summarize it, optimistic rollup takes a optimistic approach and assumes that every transfer is valid, but gives users the ability to call out bad transfers. So fraud can happen, and if no one calls it out, it will stay there. But if someone does call it out, it can be corrected. Okay. And of course, this can delay things. Well, zero knowledge assumes, everyone's a bad actor, and you have to prove that your transaction is real for each one.
Yeah, Rosa Rosario. Yeah, they are scammers. Do not message them. All right. Well,
And so what? And so that brings to the cons, though, is that computing a real zero knowledge proof requires a lot of data optimization.
okay.
And there's also a thing called an initial setup,
Okay. Yes.
which is a pretty wild topic in itself.
Do we even have time for that?
No, we do not. But
I was thinking that like a year ago that we would do a setup.
yeah, I
'Cause
mean,
it's kind
all
of like
these
the whole
different,
ceremony.
the problem with all these different topics is this is
Extremely
like,
dry.
yes, but also extremely complex.
Yes.
So there's like 10 hours of content to explain all these things.
Mhm.
But interesting to note is advances are being made so that they do not require a centralized scheme.
Okay. Well, that's kind of like our initial zero knowledge stream today. Yes.
Yeah, but the real conclusion is ZK Snake, the first practical implementation of these things. And it's on mainnet. Sync.
I said he said snake.
Hmm.
All right.
Nope,
Yeah,
sync.
ZK sync. Yeah, we'll check that out. I know that for a fact. This will not be the last time we cover this, touch on these topics, because there are even more. Let's see. I guess there are more others out there that we are going to be covering. More specifically, there's been a lot of noise, and I want to go dive deeper on a Arbitum roll up.
Hey, my cat says hi.
Okay. Snake or
Oh.
sync? Which one? It's sync. SYNK. Like NSYNC. Like me and you, Scott.
Yes, ZK Sync. You're syncing all your payments through zero knowledge.
Mm-hmm.
And this is on mainnet, and it has the potential to increase token transactions to thousands of tokens per second.
Yes, and that's not the only thing holding us back, but one of the many things that are an obstacle between us and adoption.
Yeah, and it's actually been a dream for years now.
Now your dreams
Yeah.
are a reality, John. How's that feel?
Pretty good, I guess.
Because you kind of told me like a fantastical story about you in Japan, slightly intoxicated,
Yes,
learning about this. I was like,
Yes,
that sounds
but-
fantastic.
it was fantastical. Because there was this demo where you didn't have to pay gas and everything just worked instantly. And everyone was like, at a party, like looking at our phones, like, how does this work?
Mm-hmm.
And well, that's what DevCon is. It's like every dApp developer is just like, check out my new app. It's like all the coolest stuff is revealed there.
I know. I feel left out. I haven't gone to one yet.
Yeah, and 2020 DevCon isn't looking too promising.
Oh yeah, for IRL, unfortunately. Yeah, that's why we're streaming and we're not hanging. Oh no! See, Ruth Barron. Ruth Barron is another person who's scamming. Do not message them. Eric, do not message that person. I wish I had access to that. I'll probably like 2021 DevCon in Colombia. 2021 DevCon in Colombia, is that true? Bogota? Okay.
Yeah, we're gonna have to live stream from there.
That would be a hassle. It's already hard enough to do right here. Like coming to you live with my big ass screens in Colombia. No way. Yeah, we're gonna go touch on more of this later. thank you for everyone who is watching, and I hope that not everybody came to see the Trading Tuesday, because that's what the stream title was. But see, what's supposed to be in Las Vegas this year? Oh, that's good. I don't really like Las Vegas. Last time I was there, I was near the Grand Canyon and I was like, do we want to go to Las Vegas? No. It's supposed to be in Vegas, isn't it? All right. Well, thank you everyone for your time. Hope everyone got something from that. I really had a very elucidating time this evening. So thank you. And check us out on next Wednesday. I'm going to try to keep on bringing the stream quality up. These DeFi farmers love Vegas. All right. Thanks, everybody, and good night.